Hi, this is part 2 of chapter 7. We started discussing the physical properties of liquids, including um, viscosity, surface tension, vapor pressure, and the dynamic equilibrium, and also the boiling point where the water or the liquid boils. So, I have a question. Select the compound which has higher surface tension. So, we can see this compound. I know it's just a little bit, but it's the compound is like bigger. So it has so when the compound is bigger, it has a stronger air like bigger area to have the intermolecular interaction. So this one has the higher surface tension. So now I'm moving to a new section which is energy and physical changes. So what is energy? So we talk about now solid properties, liquid properties, and then inner. So now I'm going to next topic, which is energy and physical changes. You need to know what is energy. Energy is ability to do work or produce heat. How do you calculate this energy? We're looking at the equation, which is heat is Q, it is specific heat capacity. This is a constant. Mass delta T is temperature difference. So think about you heat water. Mass of water goes here. Delta T, you start heating water at the room temperature and then you go up to 100. So 100 minus 37, whatever, 32. So these are the specific heat capacity. You don't have to memorize it. It's given in the table. So you add the specific heat capacity, mass, temperature. Difference, you get the heat. So I have done simple calculation here. Calculate the amount of heat in kilojoule required to increase the temperature of 225 grams of water to 25.2 to 90. So Q equals specific heat capacity M delta T. Specific heat capacity of water is 4.184, and then the mass is given, which is M is 255, delta T 90.5 minus 25.3. So you add everything, you multiply everything together, you get delta T. Sorry, Q. So this is how you find the Q. There's an equation to find the heat. So you can see when we do the physical changes, what are the physical changes? Water, like ice, can be melting. So ice is a solid. Melt, go to the liquid. You slowly go to the solid and liquidy phase, and then it goes to the liquid. Solid becoming liquid. Solid, you add energy and goes to a liquid. Solid goes to liquid, we call melting. Also fusion. Liquid becoming solid is freezing. So the energy and the physical change is called heat of fusion. The energy required to melt a solid is called heat of fusion. So these are the heat of fusion is given. So we need to see what is the so this process. Okay, let's go to this process. Ice becoming water. So this gains energy or releases energy. When ice becoming liquid, you need to provide energy. When you provide energy, we call it as a so they provide energy to the ice, right? So when you provide energy to ice, ice absorb heat. So we call endothermic process. But water becoming solid, the heat is releasing, temperature going down. So we call that exothermic process. So that's what changing substance from solid phase to liquid is an endothermic process, meaning we must add heat. The changing substance from liquid water to ice is exothermic, it releases heat. So vaporization. So now we did one phase change, which is ice forming liquid. Now you have the liquid becoming gas. So the liquid becoming gas, in order for the liquid to become gas, you need to provide energy. So the liquid becoming gas, you add energy, so that is the endothermic. So vaporization, endothermic. But vapor becoming liquid, condensation, you the energy is released, that is exothermic. So that's what it says, condensation, the vapor becoming liquid, that is exothermic process. So some delta H numbers. So what is sublimation? So you need to basically know these phase changes, and I'm showing you the numbers, but it's just for you to know. Sublimation is the transition directly from solid to vapor. Deposition is opposite the reverse process. It's from vapor to solid. So that's the sublimation. So there are two other phases as well. I want to look at you to look at this table. So you have solid, think about you have ice, water, and the gas phase. So the phase change, solid to liquid, we call melting, another word fusion. So you need to provide energy. And then liquid becoming gas, called vaporization. It is still you need to provide energy. And if you bypass this liquid step with directly solid becoming vapor, sublimation. Solid becoming vapor, gas, it's sublimation. Going back, releasing energy, all these are, so you need to absorb. So this is the all endothermic processes. Go down, gas becoming liquid. So you need to, what you need to do, you need to provide energy. So it is called a condensation. Sorry, it's called, yeah, condensation is gas becoming liquid, and then liquid becoming solid. When the liquid becoming, it releases energy, right? So all these processes, the temperature is going down. So all these, the blue color processes are endothermic processes, while these red color processes are exothermic. So think about melting, you need to provide energy. So melting is solid becoming liquid, you need to provide energy. Let me double check it. I did you right? Did you correctly? Let me see. I don't want to confuse it. Okay, so let's think about it. Solid, liquid. Solid becoming liquid is ice becoming water. You need to provide energy. So that is, let's go back again to the table. Ice becoming liquid. So you need to provide energy. Melting, so the temperature increase. That means it is endothermic. All these endothermic, liquid, gas. You need to provide energy to the system, endothermic. The gas becoming liquid is releasing its energy. It is exothermic. Liquid becoming solid, water becoming ice, it's releasing energy. So it is exothermic. This is exothermic. This is endothermic. What I say first is right. Endothermic, exothermic. And then when I go down, it is the question there. For each of the process, determine when energy is given off. Okay. So 1 mole of solid benzene is melted at 5.5. So Q is energy, right? So they did. So it says 1 mole of solid benzene melting at 55. So you can see it's just need some data. Okay, 1 mole of benzene when you heat it up, it's 10.09 kilojoules, and so that's 1 mole. And then the methane you have to convert into 1 mole, which is um 73.2 divided by molar mass of methane. Convert one how many moles, and you multiply by the 1 mole number, and then you get the energy. This is just one and used for you to have idea. But most importantly, you need to know in this chapter, type of solids and the phase changes. The phase changes is exothermic or endothermic. What are the names? Example, solids becoming liquid is melting. Liquid becoming gas is vaporization. Solid, gas, sublimation. The other side, gas becoming liquid, condensation. Liquid, solid is the freezing. So this is important to know. I hope this video is helpful and thank you.